Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 11 students and the topic of discussion is probability. In this video, we'll be focusing on NCERT solution for exercise number 2. In the first problem, we need to see which of the following cannot be a valid assignment of probabilities or outcomes of sample space as given by omega 1 to omega 7. One example is given like this. We are given certain numbers or certain probabilities in a sample space like this. We want to check whether these are valid assignments. So what are the steps for solving such problems? The first step is to check whether any number is negative. If any of this number is negative, then it is not a valid assignment. Second, if in this case all numbers are positive, so we'll go to the next step. In the second step, we have to check whether numbers are between 0 and 1. We check carefully all numbers. Yes, they are between 0 and 1. So it is valid for the second step. Now we'll move to the third step. In the third step, if we add all the probabilities in the sample space, it must be equal to 1. So we add up all this, we get sum of probability as 1. So all three steps are cleared. So this assignment of probability is valid. Now we have another example. We want to check whether these probabilities are valid. So first we check whether these numbers, any negative number is there, no negative number. So we move to the second step. We see that all numbers are between 0 and 1. Yeah, that is also correct. All are fractions. So second step also valid. Now we'll move to third step. We'll add all the probability values and check if it is 1. We add all the values and check it is, yes, it is indeed 1. So it has passed all the three tests. So the assignment of probability is valid. Now we'll move to another problem. In this, the omega 1 to omega 7 values are given like this. First step is to check any negative values. There are no negative values, so we move to second step. In case we find a negative value, then immediately we can say that assignment of probabilities in sample space is invalid. Now in this case, all numbers are positive, so we move to second step. All numbers are between 0 and 1, yes, so we move to the third step. Now we add all the probabilities, we are adding, we get 2.8. But we have seen that the sum of probability in the sample space must be equal to 1, which is not equal to 1. So the assignment of probability is not valid. It means these numbers doesn't make any sense from probability point of view. Let us take another problem. Here we are seeing negative numbers. Two negative numbers are there. We know that probability can never be a negative number. So this assignment of probability is not valid. In the first step itself it has failed. So we can say assignment of probability is not valid. A die is thrown, find the probability of following events. A prime number will appear. So whenever we need to find probability, we first find the sample space. So when we throw a die, sample space or the possible outcomes, it can be 1, 2, 3, 4, 5, 6. What is n of s? N of s is number of points in sample space. There are 6 points, 1, 2, 3, 4, 5, 6 in the sample space. And we need to find prime number. Prime number means out of the sample space 2, 3, 5 are prime numbers. So let A be the event of prime number. Then n of a number of times A can occur is 3 times 1, 2, 3. And the probability of getting a prime number is n of A by n of S, which is 3 by 6 equal to 1 by 2 or half. Now in the second part of this question, we need to find a number greater than or equal to 3 will appear. So greater than or 3 from the sample space, if we take 3, 4, 5, 6 we want. Let B be the event that is greater than or equal to 3. So B is equal to 3, 4, 5, 6. So number of points in event B is 1, 2, 3, 4. 4 points are there. So probability of getting a number greater than or equal to 3 is 4 divided by 6. 6 is the number of points in sample space, which is equal to 2 by 3. Fair coin with 1 marked on one face and 6 on the other, and a fair die are both tossed. Find the probability that the sum of number that turn up is 3, and second part of the question is 12. So let us try to first solve for the first part, which is 3. So when a fair coin is tossed, we can get either 1 or 6. So that's what we are writing all possible outcomes. When the result of coin, we'll fix it to 1. Then the die can be, we can get 1, 2, 3, 4, 5, 6. We have fixed the result of coin as 1. Similarly, when we fix the result of coin as 6, the die throw of die can result in 1, 2, 3, 4, 5, 6. Why we are doing like this? We are trying to find the possible outcomes, all the possible outcomes in the sample space. Then only it becomes sample space. So we have written S, which is the sample space of all the possible outcomes. 1, 1 corresponds to this, 1, 2 corresponds to this, and here we are finding the sum. We add these two, we get the sum. Now sample space has containing how many points? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 points in the sample space. But we want to get 3. But there is only 1 point for the event 3 to occur. Sum of the event has 3. So probability will be 1 over 12. That's what we are doing here. A be the event for sum equal to 3. Number of points in the for event A is only 1. Only one chance here. No other 3 is coming. So probability of getting sum as 3 is 1 over the number of points in sample space, which is 12. So we write 1 over 12. Now let us do for second part 12. Again we see that sum 12 is, there is only 1 point here. When a coin is showing 6 and die is also showing 6, sum will be 12. So again probability of getting sum as 12 is 1 over 12. A fair coin is tossed 4 times and a person win rupee 1 for each head and lose rupees 150 for each tail that turns. From the sample space, calculate how many different amounts of money you can have after 4 tosses and probability of having each of these amounts. When a coin is tossed 4 times, what is the possible outcomes? So possible outcomes can be 4 heads, 3 heads, 2 heads and 2 tail, 3 heads and 1 tail, 4 head and 0 tail, 1 head and 3 tail, 0 head and 4 tail. When we are getting head, we are winning 1 rupee. So here all heads have come, so we will profit, we will get 4 into 1, 4. Tail is 0, so we will write 0 into 1.5. 1 and 1.5 are the win and loss respectively. Similarly, when 3 heads are there, 3 into 1, profit will be 3 rupees. 1 tail will be loss. So 1 into 1.5 will be 1.5. This will be loss. And similarly, we do for other things. Now, what is the amount of money? Amount of money is profit minus loss. So this will be 4 minus 0 is 4. 3 minus 1.5 is 1.5. 2 minus 3 is minus 1. And so on. The positive means that the implication is we will get a net gain. So if either there is a 4 head or 3 heads, we are going to get a net gain. But if there are 2 heads and 2 tails, we will be losing. So for gaining, we see that at least 3 heads are required to gain. So what are the different amounts of money we get? 4, 1.5, minus 1, minus 3.5, minus 6 in the sample space. Now we want to find what is the probability for each of the events to occur. Now we see that when we toss 4 toss of coins, there is the sample space, number of points in the sample space will be 16, 2 power 4, which is 16. So we are writing all the possible outcomes here. 4 heads, first 3 heads, tail, then 2 heads, tail head, and so on. What we see here that now we need to, since we need to find the probability, we see that 4 head and 0 tail correspond to only one case. 3 head and 1 tail correspond to these 4 cases. We are taking this from the sample space and classifying under the heading 3 head and 1 tail. So we write all the possible outcomes from the sample space. So we see that 4 head case will be 1. Probability will be 1 over 16. Why 16? 16 is the total possible outcomes. 3 head cases will be 4. These 4 cases are taken from here corresponding to 3 head. So it will be 4 by 16 or 1 by 4. Similarly, we write probabilities for all the possible outcomes. If 2 by 11 is the probability of an event A, what is the probability of event not A? Probability of event not A is written as P of A complement, which is equal to 1 minus P of A. This is very important result which you should remember, that P of not A or P of A complement is equal to 1 minus P of A. So P of A is 2 by 11. So P of A complement or P of not A is 9 by 11. Check whether the following probabilities PA and PB are consistently defined. So there we are given P of A 0.5, P of B 0.7 and P of A intersection B 0.6. So for this to be consistently defined, there are two steps that it must pass through, or there are two criteria which it must satisfy. One is that P of A intersection B should be less than P of A and P of A intersection B should be less than P of B. Similarly, P of A union B should be greater than P of A and P of A union B is greater than P of B. So in this problem, we see that P of A intersection B is greater than P of A. So this is not valid. This is not consistently defined. So we write P and PAB are not consistently defined. In simple words, what is the physical meaning of this? It means that P of A intersection B should be lower than P of A and P of B because it is a subset. And P of A union B should be more than P of A or P of B because it is a superset. Check whether the following probabilities P of A and P of B are consistently defined. This is another problem. Here P of A is 0.5, P of B is 0.4, P of A union B is 0.8. Again, we have seen these two criteria it must satisfy. Let us see first criteria P of A union B, which is given P of A union B is greater than P of A and P of A union B is also greater than P of B, that is 0.8 is greater than 0.5 and 0.8 is greater than 0.4. So one of the criteria is met. Let us now find the other criteria. For getting P of A intersection B is not given. So we need to first find P of A intersection B. P of A intersection B is, or P of A union B is P of A plus P of B minus P of A intersection B. We put the values and get P of A intersection B as 0.1. Now we see that 0.1 is lower than 0.5 and 0.1 is also lower than 0.4. So the second criteria also satisfied. Hence PA and PAB are consistently defined. Given P of A equal to 3 by 5 and P of B equal to 1 by 5, find P, A or B. Whenever OR is given, it means it is a union symbol. And whenever and is given here, it is an intersection symbol. So here A or B means we need to find P of A union B if A and B are mutually exclusive events. If A and B are mutually exclusive events, we know that P of A intersection B is equal to 0. This is very important. So whenever A and B are mutually exclusive events, P of A intersection B is 0. Now we simply use the formula P of A union B equal to P of A plus P of B minus P of A intersection B. But this term is 0 already because they are mutually exclusive. So we just substitute P of A plus P of B as 3 by 5 and 1 by 5 respectively and get P of A union B as 4 by 5. If E and F are events such that P of E equal to 1 by 4, P of F equal to 1 by 2 and P of E and F equal to 1 over 8, we need to find P of E or F. So P of E and F meaning is P of E intersection F. And what is P of E or F? P of E union F. So we need to find P of E union F equal to P of E, P of F minus P of E intersection F. All these values are given here. 1 by 4, 1 by 2 and 1 by 8. We substitute in this equation. We get P of E union F as 5 by 8. Now please remember P of E union F as 5 by 8. This will be using in the next part of the problem. If E and F events are such that P of E equal to 1 by 4 and P of F equal to 1 by 2 and P of E and F is equal to 1 by 8, find P of not E and not F. So how do we write not E and not F? And is intersection symbol. So we write P of E complement intersection F complement. Complement is this apostrophe symbol. So E apostrophe is not E. F apostrophe is not F. So we write this, we need to find this. But what is this? This is equal to P of E union F complement. How do we get this? Through De Morgan's law. It is given that if A complement intersection B complement is equal to A union B the whole complement. So now what is P union F complement is 1 minus P of E union F. Again by De Morgan law we have seen here. So this is 1 minus 5 by 8. The P E union F in the previous step we have seen is 5 by 8. So 1 minus 5 by 8 is 3 by 8. If events E and F are such that P of not E or not F is 0.25, state whether E and F are mutually exclusive. So the first question is, what are mutually exclusive? And if E and F are mutually exclusive, then P of E intersection F must be a null set or it should be equal to 0. So we have to find basically P of E intersection F and check whether if it is 0 or not 0. It is given P not E or not F is 0.25 or is there, so we'll write union. Not E is E complement, F complement. So P of E complement union F complement is 0.25. Now this can be written as P of E intersection F complement equal to 0.25. How do we transform this to this? Is using the De Morgan's law where A intersection A complement union B complement is equal to A intersection B the whole complement. Through this we are writing this. Now this can be written as 1 minus P E intersection F equal to 0.25. Now substituting the values 1 minus 0.25, we get P of E intersection F as 0.75. So this has not come 0. If it was 0, then we can say that E and F are mutually exclusive, but this is not coming 0. So hence E and F are not mutually exclusive events. In class 11 of a school, 40% of the students study mathematics and 30% study biology. 10% of the class study both mathematics and biology. So we'll write in terms of probability. P of M, that is studying maths, is 40%. So we can write this as 40 by 100 or 0.4. Probability of studying biology is 30%. So we can write P of B as 0.3. Now 10% study both. So we can write P of M intersection B as 10%, which is 0.1. Now we need to find the probability that he will be studying mathematics or biology. Or is there means union we have to find. So we need to find P of M union B, which is P of M plus P of B minus P of M intersection B. P of M is, we have seen 40% or 0.4. P of B is 0.3. Intersection is 0.1. We substitute here and get P of M union B is 0.6, or 60% of the students study either mathematics or biology. Friends, with this we conclude this video. Please like and subscribe my channel so that in future videos can be released to you instantaneously. Thank you very much, friends.